Welcome back, everybody. Oh, yes, to the bell. To another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Gu. This is Unit 10, Notes number 4, and we're going to be learning about E today. And one of the applications of E. So, here we go. First of all, you guys know what pi is, right? Yeah. You guys know about pi? You know about pi? Yeah. Right? Okay, so basically, oh, you love pi? That's great. All right, so pi is a very, it's a famous number, 3.14, whatever, right? E is also another famous number. That's what it is. It's a famous number. So E, and it's called Euler's number. Yeah, it looks like Euler, but the guy's name is Euler. Euler's number. He discovered this naturally. And the number E is a number that goes on forever, just like pi. But this one is 2.71828. 1828, 45, 90, 45, and then a bunch of other numbers. But those are the starting values. It's actually really easy to memorize this because there is a kind of a pattern. It's 2.7, then it's 1828 twice, and then it's 45, 90, 45, which are angles in a triangle, So for all those guys who still single for Valentine's Day tomorrow, easy way to pick up a girl right here. Just spit out some numbers. All right, anyways. Okay, so for pi, right? Pi is useful for finding things when you're dealing with a circle. You know what I mean? You're looking for, circumference, right? Area of a circle, you need pi. Now, why is this number important? This number is useful for describing continuous growth of living things. Now, first it's applicable to living things, but then, of course, we as humans care a lot about money, so then a lot of times we use this to describe money as well. Okay, so you know how scientists say things like, the population of monkeys over here is like 25,000 or whatever, and in 3 years we expect it to grow to whatever, right? Or when scientists say like, yeah, the whale is going to be extinct in however many years. How do they estimate this? They have to use this number because this number describes the natural growth rate or decay rate. All right, so because it's natural and it's used for a lot of nature things, it's all often called the natural base or the natural growth constant. But notice the key word here is natural, right? Natural has to do with nature. And just a little tip over here, this is obvious, but it's going to come in handy tomorrow, the next day, is that this number, right, it's close to the number 3. But it's not quite 3. Right? You see that if you rounded it to 2 decimals, it's 2.72, right? Pretty close to 3, but not quite 3. We got one more thing to write down, and then that's all we're going to write in the space. It's just the formulas. Okay, so we're going to look at one way we can use this number, and it's going to be in the continuously compounded interest formula. Or this is actually the same thing as continuous growth. Same concept as continuous growth formula. But, like I said, we like to apply things to money because we care a lot about money, so we use the continuously compounded interest or continuous growth. Now, real quick, just to describe to you guys what continuously compounded interest is. Does anybody know what flat interest and continuously compounded interest, what the difference is? Anybody know the difference? All right, I'll take your silence as a no. Okay, so check this out. You don't have to write this down, but I want to illustrate to you why this is important. And also, this is applicable in real life, especially if you're depositing money into a bank account and it's flat interest or if it's compounded interest. Which one's going to give you more money? That's kind of interesting, right? So let's say you deposit $100. That's a very small amount of money, okay? But at least to illustrate the point, $100, and you're going to get 5% interest. Let's do 10%. You're going to get 10% interest in 2 years. So if you put $100 in the bank account, you get 10% interest in 2 years. How much money would you have in 2 years then? $110, right? $110. Because after 2 years, you get 10% interest. That's $110, right? Now watch this though. I'm going to do the same thing. I'm going to deposit $100. I'm going to get 10% compounded interest over 2 years. Compounded interest goes like this. At the end of each year, you're going to get some interest. So I'm splitting 10% over 2 years, right? So how much interest would I get each year? 5%, right? So watch this. The first year, how much money would I have at the end of the first year? $105, right? I'd have $105 on year 1. Now year 2, I'm not taking 5% of 100 because now I have $105, right? So I'm taking 5 more percent. I need a calculator for this one. 5 more percent of $105. So 105 times 0.05 is $5.25. So the second year, I'm getting 105 plus $5.25. So notice I come out on top with $110.25. It's very minimal, right? But the idea here is you see that because you're getting paid interest each year, it's compounded, that you actually end up with a little bit more money, right? So obviously the more money you put in there, the more money you get for free back, right? But this is the idea, just showing you the difference between flat interest and compounded interest. All right, so let's see a formula for this, how we can find compounded interest. So the formula is going to be A equals P times E raised to the R times T. A equals PERT. PERT. Very easy way to remember. A equals P times E raised to the R times T. Or PERT. Actually, I'm going to change this green to brown so you can see it better. There you go. PERT. What do each of these things mean? Does anybody know what A means? We did something like this before. A is the final amount. Usually you're looking for that, right? You want to know how much money you have, or how much of something you have at the end. So if A is the final amount, then what do you think P is? What kind of amount do you think P is? The starting amount, right? They call it the principal, that's why it's P, but it's the starting amount, right? P is the starting amount. Now E, remember E is just our number, right? E is our Euler's number, the natural growth constant. Has anybody remembered what that is about, what the number is about? If you rounded it to 2 decimals, do you know what it is? 2.72, right. You want to kind of remember that, 2.72. Okay, what is R? You know what R stands for? Rate, that's right. We did learn a formula that's similar to this before, and it was rate. Now remember, they give you rate in percent, and you have to change that into what? A decimal, right. So it's going to be percent and change into decimal. Oh, wait, why did I use the green one? Oops, sorry, guys. Put that in brown. Rate is the percent changed into a decimal. And then lastly, what do you think T stands for? Time. Now this is going to be specifically time in years, okay? It's in years. So how many years pretty much? Let's look at example 1 now. We'll see how we're actually going to use this formula. So example 1 says, Suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest, compounded continuously. How much will you have in the account when you enter high school 4 years? That should be an S. Years later. Express the answer to the nearest dollar. All right, so pay attention to the instructions and pay attention to keywords. What is the keyword? Whoa, what are the keywords that lets me know that I should be using this formula and not some other formula? Right, it says right here compounded continuously. That lets me know that I should be using this continuous growth or compounded continuous interest formula. So the formula is A equals PERT P times E raised to the R times T. So let's see what each of these things are then. What is P going to be? 3,000, right? That's the starting value. E is our constant, right? Right, E is about 2.72. But in the calculator, you have a button that says E. What's the rate? 0.05, right. It says 5%. Why do I keep putting that in the green?
So E is always going to be 2.7?
Yes, that's just like pi is always 3.14, right? Same idea. So rate 5%, we're changing that into decimal, right? So we got to move the decimal spot 2 spaces, so it's 0.05. And what is your time? 4. So all we're going to do, oh, I put green again. So all we're going to do is plug in all these numbers and see what we get in the calculator. So equals 3,000 times E raised to 0.05 times 4. So somebody put that in the calculator. The E raised to button on your calculator looks like E raised to the X. Okay, you see that thing? E to the X on the calculator. Is it what?
Oh, I see.
Yeah, it's where is it on the thing? It's
It's literally by the 10x thing.
yeah, it's like 2 buttons left of 1. All right, so put that in the calculator. Tell me what you get. 3, 6. What else? 0.42. Should be about. It should be like 4.2,
Yeah.
like this, right?
Yeah.
1, you said, yeah. Okay, and you put 3,000, and then you press the E to the X button that's next to the 1, kind of it's left of the 1. Then you put 0.05 times 4 in the exponent spot. Okay, but 3,664.21. What should my final answer be, though? Not quite. What does the answer ask? What does the question ask you to do? Round to the nearest dollar. So what's your final answer?
That's the same because you can't round it either. Or would you round to 6? No?
3,664. Because this right here, it says $3,664.21, right? We're rounding to just dollars, so we don't want any decimals. What else do I need to put here, though? Dollar sign, thank you. We're talking about doll hairs. And that's it. Very interesting, no? All right, let's look at number 2. Number 2, the frog population on an island in 2011 is 15,000. The frog population grows continuously at 2.5% per year. Find the approximate frog population in 2021. So what is, first of all, what's the keyword that lets you know to use this formula?
Grows continuously.
Grows continuously. Very good. So let's find out our variables then. So what is P? 15,000. What's E?
3.72.
Right, that's the natural growth constant. What is the rate? 0.025. Because look, we got 2.5, right? To change it in decimal, you got to move the decimal 2 spots to the left. 1, 2. Any empty spaces, you put a 0 there. See that? So 0.025. And what is my time? 10 years. How did you get 10 years? Starts at 2011, goes to 2021. So 2021 minus 2011 is 10. All right, so we're just going to put this into our formula. So A is going to equal 15,000 times E raised to 0.025 times 4. Somebody put that in the calculator and tell me what you get. Yeah. So what answer did you get? That seems a little off over there.
I got 19,260.4.
Point what?
4?
0.4, okay. All right, now what should your final answer be then? Because read the question and what it asks you. Find the approximate frog population in 2021. That's right. So why did you cut it off at just this whole number? Yeah, you can't have 0.4 of a frog. Now think about it. 0.4 of a frog would be like the arms or the legs. That's not even alive. That wouldn't count towards your population, would it? So 19,260, right? Just like, in this classroom, I wouldn't be like, we have 23 and a half kids in here. Oh, that guy's in the corner. He's dead because he lost half his body. Doesn't count. So yeah, population, whole numbers. Right, this is where you have to pay attention to the details of the question. Okay, last example here. Example 3. As a gift, Mary's parents invested $5,000 into a savings account when she turned 5 years old. Wow. The account pays 5.5% interest compounded continuously. Mary wishes to withdraw the total amount of money when she turns 18 to pay for college. So how much money will she have? So let's get our variables here. What is P?
5,000.
5,000. Yes. What is E?
2.72.
Right. What is the rate?
0.055.
That is correct. 0.055, because if we start with 5.5, we move the decimal 1, 2. Got to fill in the 0, so 0.055. That's right. And what is the time here?
13.
How did you get 13?
18.
Right, 18, because that's the ending time, minus 5, which is the beginning time, which leaves me with 13 years in between. So let's put this into the formula, and it's going to be 5,000 times E. Yeah, you don't actually have to write E as 2.72, because you just got to know that E is a constant number, though. E is never going to change. Raised to 0.055. Wow, it's tiny. Times.
10,220.9.
You got 10,000.
920.9.
Uh-huh. What else? Give me some more decimals.
That's all I got. I didn't get nothing else.
Oh, you put 2.72, right? Use the E button that's next to the... you did? And just cut it off at 0.9? That's really weird, because it should come out as 0.933, right? And let's just say you actually got this right. How would you get your final answer? What should your final answer say?
Round it.
To what?
It would be 10,221.
10,220. And I heard somebody say it. 0.93. Why did you actually leave the decimals this time? Exactly. It just says how much will she have. It doesn't say round to the nearest dollar. This time you can have cents too. This person's really really stingy. They want all the money they can get. They want the cents. All right, so 10,220.93, which means that this is, what else do I need to include in my answer? Dollar sign. $10,220.93 is the final answer right here. And that is it for today's notes, guys. So until next time, see you later. Peace.